And finally, in this last video in this trigonometry series, we have transforming trigonometric graphs. Like I said in the previous video, a lot of, like, all of the rules are the same. So where the transformation is within the function determines how the graph actually responds. So again, if it is outside of the function, so then it is a change in y. If it's inside of the function, then it is a change in x. If it is a multiplication or division, it affects the stretch. If it is an addition or a subtraction, it affects it becomes a translation. Negatives are still reflections. And that's it, really. That's all we need to know. So I've got 3 different examples, one using sin, one using cos, one using tan. Usually in an exam it would tell you to draw them on separate axes, but just for ease I'm going to do them all on the same one. I have drawn the original curve here because, again, it's always helpful to remember what the original curve looks like and where all of your key points are to be able to then transform it. And I'm going to try and use different colours for each different question. So I'm going to grab a green there as well. Okay, so the first one, we're going to use this green and we're going to do y equals 3 sin x. That 3 is outside of the function, like it is not directly affecting the x value, which means it is a transformation in y. Any transformation in the y direction behaves like you would expect. So this is a multiplication of 3, which means all of your y values are going to multiply by 3, and it is going to be a stretch in the y direction. So our graph, instead of only having limits of 1 and -1, it is now going to have limits of 3 and -3, which is why I've made my axis a little bit bigger. All of the x points are going to stay the same. So all of the intersections with the x-axis are going to stay fixed, but it is my y that is going to change. So it is going to look something like this. It's going all the way up to 3 at 90, back down through 180. Just mark it out first. And it's going to come down to -3 at 270, and then back up to cross the x-axis at 360 again. And that's it. That is all we have to do to transform that graph. Okay, lovely and simple. The next one, no, I'm still doing it between 0 and 360, it's fine. We are doing -1 plus sin x. Now again, that -1 is not directly affecting the x, it is affecting the function, which means it is a transformation in the y direction. Yeah, I really doubted myself there. Yeah, it is a transformation in the y direction. Remember, we are translating the original line, so this black line. I'm going to use blue to do it. It is a translation, so it's just going to move the line down by 1 unit in the y direction. So again, instead of going and of having limits between 1 and -1, it is now going to have limits between 0 and -2. It's going to look a little bit different. So it's going to start down here at -1. It'll go up to 90. It will come down. Oh, my line's behaving strangely. It's going to come down to -2 at 280. And then it's going to come back up. Yeah. What I'm kind of imagining whilst I'm doing this, let's just use a really light grey to show you, like this -1 is now my x-axis, like my new x-axis. So I'm thinking, okay, my line has to cross that y equals -1 line when we get to 360. So that's kind of what I was thinking in my head. I've kind of imaginary moved my x-axis down a value, a unit, if that makes sense. Remove that so it doesn't confuse us. And then the final one, so this was the blue line. And then finally, we're going to use the pink to do y equals sin 2x. Now that is directly affecting the x value. So this is going to be a transformation in the x values, our y. So we're going back to staying between -1 and 1 as our limits of the graph. And it's going to change in the x direction. Now remember, when we are directly affecting the x, the transformation behaves in the opposite way that we would expect. So this is multiplying x by 2, which means actually on our graph that changes to dividing all of our x values by 2. So instead of, what we're going to get is more oscillations of the wave between 0 and 360, because we are shortening the length of the interval, if that makes sense. So instead of going 0 to 91, we are going to go 0 to 45 So it's going to cross here. I'm going to mark off some key points. Instead of the intersection of the x-axis being at 180, it's now going to be at 90. We're going to get to -1 halfway between 90 and 180, which would be here. It's going to cross at 180. So it's starting to look something like this. So we are getting double the amount of wave for what we had before, because we have halved the length of it in the x direction. And I'm going to continue that. So it's going to go there, here, and then back up. So like so. So on our original y equals sin x, you can see we get kind of 1 maximum and 1 minimum within that interval. Now, because we have half the x values, we get 2 maximums and 2 minimums. We have doubled the amount of oscillations of the curve of the wave that we got before. I'm not sure if oscillation is the right word. It sounds very scientific-y, but I'm sure it's right. Yeah, and that's it. So those are your basic ones anyway. Your kind of stretches, squashes, translations, but we will look at how we can do it on a cos graph and a tan graph as well. Obviously, tan is where it gets a little bit trickier. But yeah, let's go. So now we have sketch within the interval -540 to 540. That is quite a big interval, mainly because of one particular part of the question. So I just made it the same for all three. It wouldn't usually be such a big interval, but you know, we'll go with it for now. So sketch within the interval -540 to 540, y equals 1/2 plus cos x. So the first thing we are doing is a translation. So we move in the y direction and we are going up 1/2. So it's moving up again, as long as it is a transformation in the y direction, it behaves as we expect. So it's 1/2 plus cos x. So we are moving the graph 1/2 of a unit up. So now, instead of starting at 1, it is going to start at 1.5, which would be here. I'm using pink to start off with. So it's going to start here. It's going to go between 1.5 and 1/2. So my graph is going between like these two. That's not true. It's going between 1.5 and -1/2. So that is down here. So we're going between these two lines. Y equals 1.5 and y equals -0.5. Nothing else is changing. This line here, this dot here is going to be where like my new x-axis is. That's where I've got confused, because it's moved up 1/2. So my graph is going to look something like, oh, I find this really difficult. So it's gonna look like that. That's right. So this, yeah, and then it's gonna come all the way down to here and then go back up again, cross there, keep going up to 1.5, come back I feel like I've messed that up. I was trying to like keep it parallel and I've messed that up a little bit. It should go, yeah, negative 360, 1.5, and then it would come down and then it would go 450, 0.5, like that, and then would continue on. Yeah, and then obviously we need to do that in the other side as well. So we're going to go here. I find it easier to kind of plot in some main points so I can join them up. Like that, and then like this. That's better. I can join that up much easier and nicer. And then it is going to do negative 450, 0.5 there as well. And then it would be negative 540, negative 0.5, like so. So that is what your graph would look like. Obviously, if you're plotting in those key points, you're hitting all of the things you're going to get marks for anyway. It's those key maximum minimum points that you can clearly see and identify that are going to get you the marks if you were doing this in an exam. So make sure use them to help. Is kind of my point. Right, next one, cos y equals cos of x minus 90. So again, we are inside of the function now. We are directly affecting x. So this is going to be a translation or a move in the x direction. Now again, it behaves in the opposite way to what you would expect. So if it is negative 90, we are going to move 90 in the positive x direction. So it's just going to be a shift by 90 degrees to the right. So instead of instead of this point being at negative 90, it's now going to be here at 0. And it's going to go up. Yeah. And it's going to go to 1 at 90. It's going to come down, cross at 180, go down like this, and up again, and then like that at 450, and then back down and cross at 540. We do the same in the negative direction, so it's coming down and up again, getting to the maximum at 270, coming back down, a minimum at negative 450, and then back up to negative 540. Now, what you should notice is that by doing that, by doing that translation, we have now created the y equals sin x curve. So cos of x minus 90 gives you the same curve as the sin curve, just by translating at 90 degrees. So you have a trigonometric property there in that sin theta is equal to cos theta minus 90, which, I'm sure will come in useful at some point. Finally, we have this y equals cos x over 3, which we use green for. It is directly affecting the x value. It is within the function, which means it is going to be a transformation in the x direction. So because anything in the x direction behaves in the opposite way that we would expect it, x over 3 is a multiplicative relationship, operation, if you will. So that means because it's instead of doing x divided by 3, all of our x values are going to get 3 times bigger. So we are going to particularly look at where all of our x-intercepts are, and we are going to multiply them by 3 to find where the new ones would be. So now instead of going straight from our maximum point here to 90, we are going to go 3 times bigger than 90. So we're going to go all the way to 270 and cross there, and the same in the negative direction. So we are getting a big fat curve there. Our minimum point is at 180. 3 lots of 180 is 540. So our next minimum point is going to be all the way here at 540, and then the same on the other side. That is a terrible drawing, but you get the idea. We've got the maximum and the minimum points that we can get in there to show that the curve has been stretched out a lot, 3 times as much to be exact. Yeah, okay, and that's that. That's the transformations on the cos graph, and finally we are going to look at 3 on the tan graph as well. So here we have y equals tan x within the intervals -360 and 360. We are going to do those 3 transformations to it, and then we are finally done. The first one is y equals negative tan x. So all of that is a transformation in the y direction. All of our y values are going to change sign. If it was positive, they're now going to be negative. If it was negative, it's now going to be positive, which is essentially a reflection in the x-axis. So our graph is going to kind of flip over. So instead of going in this direction, it's going to go in this direction instead. So it is going to look like this. So remember in the asymptotes, because it is never going to reach 90 or -90, and it's going to look like this. So have a go. It's really difficult to draw. This one would be, down here, like, difficult to draw when you can see the other one, is what I was trying to say there, but I kind of only half finished my sentence. And then keep going all the way to 360, and then this one is going to look like this. So there you go. There is a reflection in the x-axis. It makes a very pretty pattern. The next one is y equals tan x plus 45. It is affecting the x. It is within the function, which means it is a translation because it is additive. It's a translation in the x direction. If it's plus 45 though, that means we are taking 45 away. So all of our x values become 45 less. So instead of what's best to do is find where all the asymptotes would be, where all of our intersections with the x-axis would be. So instead of crossing at 0, it's going to cross at -45. All of our intersections are going to be 45 less. I'm trying to figure out which ones I'd actually be able to see on this graph. So it would look like that. I'm going to draw in some really faint asymptotes, I think, using this lovely grey colour. So where it was at 90, it's now at 45. Let's use a straight line. So it's going to be here. Where it was at 240, it's going to be like that. We had an asymptote at -90, it's going to be 45 less than that. And we had an asymptote at -270, so it's going to be 45 less than that. So it's going to go between those kind of sections. Let's draw it in. So our line is going to look like that. Oh, I appear to be drawing smooth curves. Like this, and then that should be crossing that there, but you know what I mean. And keep going like so, and then like this. That wouldn't be. Yeah, there would be an asymptote there, but it wouldn't cross at 360. But we do need to make sure that our graph reflects that it's going between -360 and 360. So it's starting to look very confusing with all these lines, but I hope you can kind of see what I'm doing. The last one is another reflection, but this time it is in the x direction. Now the funny thing with a tan graph is if you do a reflection in the y-axis, it actually ends up looking the same as if you do a reflection on the x-axis. Is that right? Yeah. Yeah, so again, it's like taking all of your intersections with the x-axis and making them negative now. So instead of it crossing at 180, it's now going to cross at negative 180, and kind of go in the opposite direction. And the same with where it was crossing at 360, it's now going to cross at negative 360 and go in the opposite direction. So it ends up just looking like this green line that we've already done. So that saves us doing another line onto this graph. And that's it. Those are all of the different transformations of trig graphs that I wanted to show you. And that is everything that we needed to know for this chapter on the A level. For trigonometry. So I hope that makes sense. I hope you've understood and I hope you followed it along. Thank you for listening. Again, I know these haven't been short videos, but they are definitely worth spending a bit of time and just re-familiarising yourself from IGCSE trig, so that we can use it now in the A level as well. Or if you're doing IGCSE and familiarising yourself with it regardless, because it's new. So I hope it's helped. Thank you for watching and have a lovely